Okay, welcome to the tutorial 3. In the last tutorial, we made the schematic view of a CMOS inverter, then we made the symbol of that. Today, let's do the layout of the inverter. It's a simple circuit. First, let's do the schematic and symbol once again. Okay, file new library. Layout. Okay, new cell view. Okay, new cell view, where it is. Okay, inverter. Okay. Let's be the minimum size. Okay, press I, add instance. We need a PMOS now. Okay, let's make the width double of that NMOS. 240, 480. Hide, place it, press F, fit, zoom out, then add wires, press W. Okay, press W. Now add pins. We need 3 pins. Add pin, or just press P. Input, we need one input in, just name as in. Okay, so yeah, it's connected. Press escape, then add one more pin named out. It is an output pin. Hide, place it. Now add VDD. It's input output type. Okay, now add ground pin, TND. Hide. Okay, check and save. No error. Our schematic is complete. Let's create a simple view of that. Okay, paste. Okay, fine. Press F, delete all these. Yes. Okay, create shape line. Or it is not needed, you can just delete this also. Okay, that's also fine. Close it, and check the library manager. Now you can see we have the schematic view and the symbol view. Now yeah, before doing the layout, just simulate this inverter cell view. Just make a test bench for that inverter test. Okay, add instance, browse. Simple, close, hide. Press I, add instance. Just make power supply, analog library, VDC, small VDC, hide DC voltage, put 1.8 volt. Okay, and V pulse. Okay, 1.8 volt, period 1 microsecond, pulse width 0.5 microsecond or 500 nanosecond, that's fine. Place it, insert ground. Okay, yeah, now just wire it up. Add label or just press L. You want input and output. Okay, hide, place the first one here, second one here, check and save. To warning, the warning is because this node is floating, it's not a problem. Okay, then we are ready to simulate now. Launch ADE, transient analysis, 10 microsecond enabled. Okay, setup outputs, select from schematic. We need to plot input and output. Yeah, they are ready to plot. Let's simulate. Yeah, yeah, before analyzing the output, I just want to see the log file of the simulation. Here you can see we have a total 3 nodes, and BSIM model is basically the MOSFET. We have 2 MOSFET in the design and 2 voltage source in the design. This is the total things in the circuit. We will come back to this later, and let's analyze the output. Just zoom the output if you want in the X direction. Go back if you want to zoom in the Y direction. This is the method. Go back, and you want to see this is the input, this is the output, this is the input. If you want to see separately, press here. Is the yeah, it's a perfect inverter. Okay, fine. Now yeah, we want to save these settings so that we can save time sometimes when we do this later. Save state, cell view. Okay, yeah, now you can close it. Close this one also. Okay, now make the layout of the inverter. Open it, launch, layout, new, create new, that's fine. Keep in mind that the name should be same for the same cell. Name is inverter itself, but the view has changed. It is now layout now. Press OK, and let's see. Yeah, just minimize this. What's new inverters are not needed, and okay. This is our layout window. Press F, and this is LSW. LSW means layer selection window. You can select different layers here: metal, polysilicon, metal 1, metal 2, metal 3, like that. So let's start. Before starting, the entire black surface here, this is the P substrate. So you need not to create a P substrate here. The total black surface is a P substrate, but for the NVAL you have to create a separate NVAL that you will learn. Okay, add instance, browse, EMC18 CMOS. First add the NMOS, add the layout of the NMOS. Okay, let's check the size of that. 240, 18 nanometer height. Let's zoom it. Press F. Place the NMOS. Now add the PMOS. The size is 480, height PMOS layout. Okay, press F. Yeah, we want to see the what is inside this cell. Go to options, display level, increase the display level to 10 or something. That's fine. See, even though these two cells look almost the same size, you see where is this difference. Actually the width is here from this point to this point. So this is here the width is this point to this point. So here it is almost yeah, correctly exactly double of that. Don't worry about it now. Press F, and this is the NMOS and this is the PMOS. PMOS is inside the NVAL. This total thing is the NVAL. Okay, check our schematic once again. Where is it? Yeah. Now see, in the schematic, the NMOS and PMOS here, the gate of NMOS is connected to gate of PMOS. Let's do that first. Here, press F. First connect the gate. This is the gate of PMOS. Press F. This is the gate of the PMOS and this is the gate of the NMOS. Let's connect them together. You can use the poly itself. So type here PO1. PO1 is the poly, and let's zoom it out and create shape rectangle. So you can use the shortcut key R. Escape, press R, click, press R. Before that, go to display, make it something fine, diagonal. Yeah, okay, fine. Press F. Connect we are connecting the gates together. Press R. Yeah. Press F. That looks fine. Now the gates of the two MOSFETs are connected through poly. Now check the schematic again. Now let's do this connection. The drain of two MOSFETs are connected, so let's do that. Select metal 1 for that because it's already using metal 1. ME1, type ME1 here to select metal 1, and let's zoom here. Press R to create a rectangle. Okay. Press F. Looks fine. Now let's check the DRC. Is there any error? The DRC is design rule check. Okay, technology is UMC 18. Okay, okay. DRC is running. Yeah, it is showing a lot of error, right? Yeah, it is showing. Okay, where is that error? Okay, no, basically these errors are because we didn't made any connection to N well or to P well. So first make them, then some of the DRC error will be reduced. So create via M1 metal 1 to N well. Okay. Place it here. Press F. Create via. Now we make a connection to the P well. Okay, press F. Run DRC again. Okay, okay. Minimum metal area, where is it? Yeah, that error we will rectify later. Now let's go to schematic. We had this connection. Now connect the source to ground, source and the bulk to the ground. So this is the source. Press R. They are connected. Now the source of the PMOS to VDD and to the bulk. Press R. Press R. Okay, they are also connected. Save it. Run DRC. Okay. Yes. Yep. No DRC error. Okay, fine. Now. Okay, now we have to make the contacts to the gate. So let's select poly PO1 and press R, F, zoom it. Okay, then we need a metal 1, type ME1 here and press R. Okay, looking good. Now we should create a via to poly from metal 1. Create via metal 1 poly, hide. Wow, it's too big, right? Yeah, so we can make it, just rearrange all these things. Oh, oops. Select both of them. Okay, fine. Let's make them once again. O1, press R, whoosh, press F, fine. Before that, may complete this one. Okay, select metal 1 now, ME1, press R, create via metal 1 poly, hide, place it, press F, save, check the DRC. Okay. Yeah, what's the error? This here error is coming. Okay, we didn't connect. Oh, is this an error? Let's see. Press R, connect them, press F, save, check DRC. Yeah, fierce poly is again showing error. Here it is. So what's the error? Field poly spacing is 0.24 micro. Check the distance. Oh, okay, that's error. F, check and save, run DRC. Okay. Yep, yeah, no error. See, now we haven't even labeled the devices. We don't know where is input, where is output, but still DRC is showing no error, because DRC will check only the drawing is correct or not. It will not check any connection. So who will check that? Who will check whether the layout and the schematics are matching? That is LVC, layout versus schematic check. So if you before doing that, you should create pins, because in the schematic you have 4 pins, VDD, ground, in, out. So you have to create those pins. Create pin, put VDD, input output type here. Now label it VDD, fine. Similarly, ground, label it GND, hide. Now out, out, in. Okay, create pin, in, hide, label, in, hide, in. Press F, save, what's this? Okay, save it, run DRC. Okay, yes, no DRC error found. Now go to LVS. Okay. Yeah, LVS is also ready. No error. Now so you will see the report as here. Inverter, the schematic and layout match. There is no error. Now you can see. Press F. If you select this M0, this is this one. You can see the corresponding change here also. It is M1 now highlighted. It's M0 now. The ground input, output, VDD, and all. If yeah, now the LVS is also over. Now let's make some mistakes so that we can learn what are the possible errors. You know, use the metal one. What is the LSV? Yeah, metal one. Just short the input and output by just create some wire. Press R. See, accidentally you short them. Press F. Save it. Ashura DRC. Okay. See, design rule will not give any error because it is possible to pass metal one above poly one. So by design rule it is not an error. But if you do that LVS, it is going to give error. Okay. Yeah, LVS is showing error that one cell had nets mismatches and all. Press OK and open the this is the LVS debug inverter. It is showing one short. Open the tool. It is saying in out is shorted. Let's zoom in. It is saying it is shorted. Okay. Now just remove that. Fine. Now save. Okay. Now let's make one design rule error. What design rule error we can make? Yeah. See, this whole thing is your N well. So if you move this apart, your N well will be break. Your N well will become too small N well. So it is a violation of design rule. Save it. Ashura run DRC. Okay. It should show error. Let's wait. Yep. Yeah. Minimum equal potential spacing is the problem. So put it back. Looks good. Run DRC. Okay, yes. Yep. No DRC error. Press F. Run LVS. Okay, inverter. Okay, that's fine. Okay. Yep, that's also correct. No error. Now we are now let's proceed and simulate the things. Before that we have to extract the parasitics of this circuit. For that Ashura run QRC extraction. Reference node is ground. Power node we have VDD. Ground node is ground of ground. Okay, that's fine. Run it. Yes. Yeah, QRC is also successful. Close it. Now let's close this or go to the library manager. Now you can see in the inverter you have a schematic, this one, then you have the symbol, now you have the layout that we made, and one more thing is the AV extractor. This is the extracted view. See, this is the extracted view of our inverter. If you zoom it, you can see a lots of this one is the resistors, capacitors. We didn't put any resistor or capacitor. Yeah, these are the parasitic capacitance and the resistors. See, this is our MOSFET, but the parasitic capacitance, parasitic resistance, and all. Yeah, close them, and now we can simulate with parasitics and without parasitics. So go to the inverter test, file, new, cell view, create a configuration window. Okay, use template. We are using spect for simulation. Okay, it's not needed. Basic view is the schematic view. Okay, now see, this is the yeah. So this is our test bench. Here we have two voltage sources and one inverter. Now you see in this configuration also, the tree view, you have two voltage source V0 and V1, and I0 is the inverter. And if you open it, we have only two devices inside that inverter. You can go to inside this symbol by edit view, where it is, edit hierarchy, descend edit, or you can press E. See, inside that we have only two devices, one NMOS and PMOS, that is showing here, NMOS and PMOS. But now if you change the instance view to AV extracted as the extracted view, then things have changed. See, you have only two voltage sources, that's fine, same, but inside the inverter you have a lots of devices, like you have two MOSFETs and a lot of capacitance and lots of resistance. These are the parasitic capacitance and resistance. Now you change to schematic, again is the old thing, update here. Okay, close it now. Okay, let's simulate the things. Open the schematic, it's here. Open the configuration, yes. Okay, now it is only, now let's simulate without any parasitics. So launch ADE, let's load the state that we have saved. Okay, what's the problem? Let's simulate. Okay, Yeah, this is out. But yeah, here you notice we have only 3 nodes, 2 MOSFET and 2 voltage source. Now you close this, go to the configuration, set the instance view to AV extracted, update. Okay, simulate again the same thing. uh, launch DE state. Hmm, 10 micro enabled. Okay, yep. See, now we have 14 nodes and yeah, only 2 MOSFET but 23 capacitance, 11 resistors, 2 sources. So these 11 resistors and 23 capacitance are the parasitic capacitance. We didn't add any capacitance. Okay, then now we simulated the circuit with and without parasitics, and this is the end of the tutorial 3. Thank you.